Okay, you guys, I'm sorry I cannot be here with you today, but I'm going to go ahead and go over the section 8.3 that was scheduled for today. By the way, section 8.2 that was due yesterday, you were supposed to have turned in that assignment yesterday. And if you haven't turned it in, please do so at this point. Go ahead and turn it in, put it on the top tray. Anybody who doesn't turn it in, it would be considered late. So please turn it in. Now, section 8.3, it's dealing with hyperbolas. This is another conic section. And hyperbolas, it's basically, the hyperbola is the least known conic section, yet it is used in astronomy, optics, and navigation. There are some parts of the hyperbola that we need to be aware of. First of all, in your textbook, this is on page 656. You can see all this information. I'm just going to go through this real quickly just to tell you a little bit about the hyperbola. It says the geometry of a hyperbola. When a plane intersects both napes of a right circular cylinder, the intersection, it's actually a hyperbola. And the definition, features, and the derivation of the hyperbola closely. It's basically pretty much the same idea for an ellipse. The definition, it says the hyperbola is the set of all points in a plane whose distances from two foci are the points in the plane that have a constant difference. The fixed points are called the foci. The line through the foci is called the focal axis. And midway between the foci is the center. The points where the hyperbola intersect, its focal axis are the vertices. So this is pretty much the same pieces of information that we have from the parabola and from the ellipses. And here you can see the parts. In the center you're going to have the point, the center, and then you have the vertices, and then the foci. I'm sorry about that, but my son is over here with me in the TV room. Okay, so anyways, you need to find out what's the equation for the hyperbola. Well, the hyperbola, it's a little different from the ellipse, because on the ellipse you had the equation with the plus sign in the middle. But in this case, the hyperbola has a minus in the middle. Okay, so it's x squared over a squared minus y squared over b squared equals to 1. And in this equation, whatever it's first, that's going to be the major axis. So if you have x squared over a squared, that becomes the major axis, which means that the hyperbola is going to be opening sideways. If you have the y squared first, then it's going to be opening up and down. That's going to be the hyperbola. Okay? If you flip the page over, you're going to see the explanation where it says the equation x squared over a squared minus y squared over b squared equal to 1 is the standard form of the equation of a hyperbola centered at the origin with the x-axis being its focal axis. But a hyperbola centered at the origin with the y-axis as its focal axis is the inverse relation of the one given, and therefore the equation is y squared over a squared minus x squared over b squared. So notice that here is y first because the focal axis was the y-axis, and over here the focal axis was the x-axis. Okay, now another piece of information that you need to be aware of is that, as with the other conics, the line segment with endpoints of a hyperbola, it's a chord of a hyperbola, the chord line on the focal axis connecting the vertices is the transverse axis of the hyperbola, which means that the transverse axis is the axis of the what we used to call in the ellipses of the major axis. And the length of the transverse axis is 2a because it's, the sum of the two a's. The line segment of the length 2b that is perpendicular to the focal axis that has a center of the hyperbola, and its midpoint is a conjugate axis of the hyperbola, which means that the conjugate axis becomes the axis of the minor axis. In ellipses is the minor axis. Here is referred as the conjugate axis. The number A is also known as the semi-transverse axis. Semi because it's half of the transverse axis. And B is the semi-half, the conjugate axis. So if the conjugate axis is 20, then B would be 10 because the semi is half of that. Okay? The last part of the hyperbola that we need to be aware of, that we need to know, is that the hyperbola has two asymptotes. These asymptotes are slant lines that can be found by replacing the one on the right hand side of the hyperbola's equation by 0. So if you let that be equal to 0 instead of a 1, and you solve for the y, after you solve for the y, you're going to have plus minus b over a x, and that would be the asymptote. It says a hyperbola center at the origin with its focal axis. One of the coordinate axes is symmetric with respect to the origin in both coordinate axes. Such a hyperbola can be sketched by drawing a rectangle. So it can be sketched by drawing a rectangle, center at the origin, with sides parallel to the coordinate axis, followed by drawing the asymptotes through opposite corners of the rectangle, and finally sketching the hyperbola using the central rectangle and asymptotes as guides, as shown in the drawing lesson. And the drawing lesson in this case is, well, first of all, we know that the equation is x squared over a squared. So this is a major axis, the x squared. So major axis, in this case we're talking about a being the major axis. X equals plus minus a, and then b plus minus b. And then what you do, you draw the rectangle from A to A and from B to B. So there's a rectangle. Once you draw the rectangle, you're going to draw the lines that go through the origin and pass through the vertices of that rectangle. So if you remember, the lines have a slope, rise over the run. So it's B over A, B over A, B over A. And when you repeat that slope, you're going to have a line that is going to be a diagonal line. If you go from these opposite corners, is you go negative B over positive A. So it's negative B over positive A, negative B over positive A. And you're going to have this line coming, which is this part, negative B over A, and this is positive B over A. Once you draw the rectangle, you draw the asymptotes. The next part is just to draw the hyperbola. So the hyperbola has to be passing through the negative A and then just approaching those asymptotes, and then positive A approaching the asymptotes. So the blue part is the drawing, is the sketch of the hyperbola for this equation, x squared over a squared minus y squared over b squared equals to 1.